Welcome, geometry students. We are here to talk about a topic that is kind of a weird one. It kind of stands alone. It's not really something that's related very closely to the things we talk about around it. It's just kind of an individual independent skill, and that is partitioning a line segment. And one of the first things I want to say is that it's not always described this way. We could also sometimes call it partitioning a directed line segment, because basically we're talking about a line segment for which we have to know where it starts and stops. It's almost like it has a direction. Like if I talk about line segment JK, there's an implication that I'm either going from J to K or going from K to J, implied in the problem. Okay, so there's some sort of an idea of there is a starting point and a stopping point, as opposed to most line segments. We're really just saying it's two endpoints with all the points between them that are on the line. But here there's a definite sort of feel of start and finish. So that's one of the first things you have to get out of your problem when you're asked to do one of these. So let's look at one of these. They can be asked different ways. Here's the first way I want to look at it. So segment MN has endpoints M, -5, -2, and N, -1, 6. Find the point that is 1/4 of the distance from M to N. Okay, so what I'm going to do first is I'm going to just very loosely sketch this. I'm not worried about a lot of accuracy, but -5, -2, maybe here. And -1, 6, maybe something like this. Okay, so I'm just getting an idea of where they are in relation to each other. Okay, so this is my segment. Now, first of all, we just talked about how this is supposed to be a directed line segment, and I'm sorry that looks a little bit curved. It says from M to N. So that implies we are starting here. This is our starting point. So we are going 1/4 of the distance from here to there. If we were doing 1/4 of the distance from N to M, we'd end up in a different place. That's why direction matters here, is because we need to know, okay, we're going 1/4 of the way, but where are we starting? So 1/4 of the way implies that I'm taking this segment, MN, and I'm thinking of it as having 4 pieces, or being divided into 4 pieces. So let's divide it in the middle, and then once on each side of that. And I don't know that it's going to be right at the x-axis, so that's kind of a tentative mark. We'll see, because again, this is a loose sketch. So we need to figure out what is 1/4 of the distance. Now, if that was accurate, if that's accurate, that's going to be my point for 1/4 of the distance, because 1/4 means I have cut it into 1, 2, 3, 4 pieces, and I'm going one of them and stopping. You notice it doesn't look all that proportional, but I'm pretty sure it's going to be near the axis. But that's just sort of my instinct on it. Let's actually figure it out. Okay, so here's one way we can figure it out. We can think about it, and this is something you can do with segments a lot of different times in a lot of different contexts, and that is think about their horizontal components and their vertical components separately. In other words, think about the left to the right, and think about the up and down. Okay, so I'm going to think about the x's separately from the y's. The x's are the horizontal components. So my x's go from -5 to -1. Okay, so from -5 to -1, if I cut that into 4 pieces, and I'm starting here, and I go one of the 4 pieces, this is where I am. So that's like maybe right here. Now the y values go from, this is the y value over here is this y value. The y values here go from -2 up to 6. So if I cut that into 4 pieces, well, let's see how far that is. That's 8, right? From -2 up to 6 is 8. And 8 divided into 4 pieces, each of these pieces is going to be 2. In other words, from -2, I go up to 0, and then up 2, and then up 2, and then I'm at 6. So again, if I'm starting at this point, which means I'm starting at the y value of -2, and I go one of the 4 pieces, then I will end up here. So that's like cutting this, both of these into 4 pieces. And I need to come up a little higher here. And that is where it's going to end up. And that point is -4, 0. So basically, I went 1/4 of the way from one x to the other x, and I went 1/4 of the way from one y to the other y. Now, when we say 1/4 of the way, that's the same idea as 1/4 of the distance. So I had to know how far it was total from -2 to 6, and how far it was total from -5 to 1. Because I wanted to go 1/4 of that total distance. Okay, that's one way they'll be asked. We're going to come back to that when we see the formula, because the formula really kind of does exactly this. Now, the other way sometimes they're asked is instead of saying a certain fraction of the distance, instead of putting it in that respect, in that notation, or that terminology, I guess is the words. Sometimes it's given to you as a ratio, and they'll say, please find us the point that, instead of saying my point is 1/4 of the distance, find the point that divides the segment into a ratio of this number to that number. In this particular case, since there's one section before we get to our point and 1, 2, 3 sections after it, because remember it was 1/4, which implies 4 total sections. We're cutting the segment into 4 pieces. If there's one section before it and 3 sections after it, we could have said, find the point that divides the segment in a 1:3 ratio. That means there's one section before you get to that point and 3 sections after you get that point. Whatever the first number is the number of sections before the point, and the second number is the number of sections after the point. Now, before we go on to one starting from it being worded that way, let's just look at how this relates to this. If I was given this, how would I know how to convert that to thinking of what fraction of the distance? Well, if I've got one part before my point and 3 parts after my point, how many total parts do I have? 1 plus 3 is 4. And then I want to go one of them and then stop. So it's 1 out of a total of 4. So the top number is the same as the first number. The bottom number is the same as adding them together. Sometimes we put this as ratio of A to B, which means this would be the same as A over A plus B. Okay, so let's look at one that's phrased that way. All right, this one says, find the point that partitions the directed segment AB in a 2:3 ratio. Now, notice that this one doesn't tell you you're going from one point to another. It just calls it a directed segment. So if it doesn't tell you which is the starting point, if it doesn't say anything in that terminology that makes you feel like, oh, they want me to start here, just start at the first letter of the segment name. Okay, so that's kind of implied if they don't tell you. So we're implied that the starting place is A. So it's a directed segment from A to B. Okay, and we are taking this segment and dividing it up in a 2:3 ratio, putting a point somewhere along it so that 2 parts of the segment are in front of the point and 3 parts are after it. So let's think about what that means visually. That means we have some point. Let's make a dot for that point. And before that point, we have 2 sections. And after that point, we have 3 sections. Okay, and we've got our starting point here and our ending point here. So how many sections total do we have? There's 2 sections before our point and 3 sections after. We have a total of 5 sections. So another way of saying I want to divide it up in a 2:3 ratio is I want to figure out how to divide this up into 5 pieces and then go 2 pieces and stop. Another way of saying that is I want to go 2/5 of the distance from A to B. It's another way of saying the same thing. I'm going to go 2 out of the 5 pieces. That's what 2/5 means. 2 pieces out of 5. So that's another way of saying that same thing. So here's what we're going to do. We're going to go ahead and we're going to look at the X and the Y separately, just like we did before. I'm going to make it to where I can examine. When you're looking at just the horizontal and the vertical components, really it's like you're drawing a right triangle. So let's look at this, and we have, here's my horizontal components. My horizontal component, horizontally it goes from X is -1 to X is 9, and I want to divide that up into 5 pieces, a total of 5 pieces. So we want to go 2/5 of the way from -1 to 9. How far is it from -1 to 9? Well, we can subtract 9 minus -1. So 9 minus -1 gives me the distance from basically the horizontal distance. Let's say horizontal distance. Sorry, I had to squeeze that in there, which is 10. And I want to go 2/5 of that. So I'm going to do 2/5 of that distance. 2/5 of means times 2/5. Or I'm going to take 2 parts out of 5. And I'm going to start at -1 and go from there. So when you're starting at -1 and going to the right, I'm going to go -1 plus 2/5 of that distance. That's basically what I'm doing here. I'm cutting this into 5 pieces, and I'm going to do 1, 2. Well, if there's 10 units total, and I cut it into 5 pieces, each piece is 2, 2 of them would be 4. 2/5 of 10 is 4. So I'm going to take -1, and I'm going to add 4 to -1. And that 4 came from 2/5 of 10, and that gets me to 3. Okay, so this is what I did in terms of horizontally. I started at horizontal, I started at my original X, and I went 2/5 of the distance from X, first X to second X. Okay, now I'm going to do the same thing here, and I'm going to do it a little bit more formulaically. I'm starting here, and I'm going there, because remember, A was my starting. So I'm going to start at my first Y is 4. And then I'm going to go 2/5 plus 2/5 of the distance from 4 down to -1. And I'm going to subtract -1 minus 4 to find out what that difference or that distance is. And it's okay that I'm getting a negative here because I have to go down. So the fact that I'm getting a negative is correct. It's going to make me go down. So 4 plus 2/5 of -5, that's 4 plus -2, which equals 2. So if I go down, this will be at 2. Okay, and that is where I will be. I will be right here at the point 3, 2. This is my Y value, and this was my X value. So now why did I do it this way? Because I wanted to lead you into the formula. Here's how the formula works. The formula does the exact same thing for the X as it does for the Y. It says, let's take your starting point plus the fraction of the total length. Now, obviously, I wrote this before I had written this, and this is not spaced out right. But you can see that that's what's happening here. I had my starting point plus whatever fraction that this ratio told me I needed to go of the total length horizontally, which was 10. Now, why just horizontally? Because we're going to do the exact same thing for X and Y. So you basically just do it for X, which is just dealing with the horizontal, and then you go back and you do it for Y. So we did the same thing here for Y. We did the starting point plus the fraction of the total length. Okay, and the total length you get by subtracting the final point minus the starting point. So here's what I want to show you. That's how the formula works. This formula looks really ugly when you first look at it, but I want you to see what's happening here. X1 just means you're starting X plus, and this is the fraction we get. Remember we said that if we have the ratio A to B, that our fraction will be A over A plus B. Okay, that's our fraction of the total distance we want to go, and this is the total distance we want to go horizontally, or the total length horizontally. So we do that for X, and then we come back and we do the exact same thing for Y, and that's all the formula is. Formulas formulas work a lot better if instead of memorizing them, you understand them. So if you understand that this is what's happening, that will help you a lot. Let's look at this fraction here. Sometimes people struggle with the A over the A plus B. Basically, that's what I did here, remember, when I said if my ratio is A to B ratio, then I have A on top. I go to 2 parts out of a total of 5 parts. The B plus A makes the bottom. The denominator is the entire A plus B because it's how many parts I have all together. All right, so now let's do one with the formula. Okay, this one, and it looks much smaller after the ones I've handwritten. So let me see if I can zoom in a little. Sorry if I'm giving you motion sickness. The line segment AB has endpoints A, -5, 3, and B, -1, -5. Find the point that partitions the line segment in a ratio of 1 to 3. So here is my A to B. Okay. Here is my X1, Y1. Here is my X2, Y2. So I'm going to use the formula. And the formula says the same thing for X and for Y. It says if you want your new X, you're going to take the starting X, which is -5, and you're going to add some fraction of the total distance between the X's. And that's -1 minus a -5. Now the fraction here, if we have a ratio of 1 to 3, that means 1 piece is before our point and 3 pieces are after the point, which means we have a total of 4 pieces. So as a fraction, we are going 1 part out of the total of 4 pieces. So that's what A over A plus B is. It's that fraction. So my X value is going to be X1 plus 1/4 of X2 minus X1. And my Y part is going to be Y1 plus 1/4. The fraction's the same for both of them. And that here is -5 plus 1/4 of -1 minus a -5. -1 minus a -5 is 4. And 3 plus 1/4 of -5 minus 3, which is -8. Okay, so the X value is going to be -5 plus, this becomes 1. -5 plus 1 is, and I'm kind of running out of space here. I'm going to add some space. There we go. -5 plus 1 is -4. And 1/4 of -8 is -2. So we have 3 plus -2, which is 1. So our point that partitions the segment into a 1 to 3 ratio is the point -4, 1. All right, let's do another one like that. Number 2, find the point that partitions the line segment CD in a ratio of 2 to 1. Okay, so let's find our coordinates. C is at, not hard to tell, -1, -1, 2, 3. So C is at -1, -3. And D is at 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 4, 4. And our fraction here, if we are going in a ratio of 2 to 1, that means we have a total of 3 parts. So we want to go 2 of the parts and then stop. So we're going to go 2 parts out of 3. So that's our fraction. So our new X, and it doesn't say from this point to this point, so we assume they mean starting with C. So our new X will be starting with the original x plus 2/3 of the way from the old x minus the new x, that's the distance. So this is a good example of why it's nice to have a formula and not just try to do it intuitively, is because sometimes it's not going to be whole numbers. So -3 plus 2/3 of 4 minus -3. 4 minus -3. So this is -1 plus 2/3 of 5. And -3 plus 2/3 of 7. So this is going to be a little fractiony. 2/3 of 5 is 10/3. So we have -1 plus 10/3, which is -3/3 plus 10/3. You have to have a common denominator to add fractions, which is 7/3. Okay, so there's my x value. And -3 plus 2/3 times 7 is 14/3. Again with the common denominator. And this gives me 5/3. And that is my answer. Let's close those parentheses, and we're going to do one more. And this time we're going to pick one that's already stated as a fraction. To me, those are easier. It says the line segment JK has endpoints -2, -3, and 2/5. Find the point that is 2/3 of the distance from J to K. So we're definitely starting with J because it says from J to K. 2/3 of the distance from JK. I just love the way this tells me the formula. It's 2/3 of the distance from J. Well, that means we're starting at J, and then we're going from there 2/3 of the distance. And the distance is subtract to get how far that is. So 2 minus -2. And again with the y's, I'm going 2/3 the distance from J to K. So from J, -3, I'm going, so I'm going to add to that 2/3 of the distance. The distance from -3 to 5 for the y's is 5 minus -3. So basically that phrase, 2/3 the distance from J to K, really tells you exactly what we're doing here. All right, so we got -2. Let me just move this up. -2 plus 2/3 of 4. -3 plus 2/3 of 8. And this is going to be another one that it doesn't come out terribly pretty, but that's okay. A lot of life's numbers just don't. A little math wisdom for us. And this is -6/3 plus 8/3. -9/3 plus 16/3. And this gives me 2/3, running off the screen, and 7/3. And that is my answer. That is the point. That is 2/3 of the distance from J to K. So I hope this has helped you. I'm glad you came. Make sure you come back, check out my other videos, and let me know what you need help on. Thanks so much. Bye.